Okay, so what we're going to look at now is a little technique for finding the degree of a polynomial from a given table of values. So if we have a table of values like this one, the first thing we need to consider to use this technique is, do we have a constant rate of change in the x values? They're going up by plus 2. Plus 2, plus 2, plus 2. This is a requirement to use this technique. Next, we look at the rate of change between these ones here, like this. So this is going, what is the rate of change from minus 2, average rate of change from x equals 1 to x equals 3? This is, well, it's not the average rate of change, actually. It's just how much has it changed? This has changed by minus 1. And from here to here? Plus 2. And from here to here? And from here to here? Now, if those numbers were all the same, what would that mean about the function? It's a linear. So if all those numbers were the same, it would mean it's a linear function, because you have a constant rate of change with a linear function. So at this point, we've shown that it's not linear. No, it's polynomial. Let's have a look. We are going from here to here. How much has the change changed? If the second rate of change, if the second change is constant, it implies it is quadratic or second degree. So we call these the differences. The blue ones are the first differences. So if the second differences are constant, that means we have a second degree. So, sorry, let me highlight it here. So the number of successive differences needed for the differences to be constant is equal to the degree of the polynomial. So because the second differences are constant, so we would write as our answer, because the second differences are constant, it implies f of x is quadratic. Let's have a look at the next one. So what are the first differences here? What are the first differences? This one is going to be plus 2, plus 10, 17, 23. What are the second differences? 8, 7, 6. What are the third differences? What is our answer? What is the reason? Because the third differences, so get used to using this expression, third differences. Because the third differences are constant, it implies, and let me see, what have we got? It's G. It implies the degree of G equals 3. Okay, odd and even functions. So we can classify some polynomials as being odd or, well, some functions as being odd or even functions. An even function has a symmetry, a reflection symmetry in the y-axis. Notice that the graph on the right is a reflection of the graph on the left. With an even function, if f of minus x is equal to f of x, then we can prove a function to be even. Odd functions have a rotational symmetry around the origin. If you rotate the right-hand side around this, it will land on the other one. 180-degree rotational symmetry here at this point. For an odd function, g of minus x is equal to minus g of x. So all you need to do for both of these is you need to examine what is f of minus x. If it comes out as f of x, it's even. If it comes out as minus x, minus f of x, it's odd. If it comes out as neither, it's not either. I will do a proof for one of these ones. Let me do this one as an example. Okay, show that the following polynomials are either odd, even, or neither. So always start by entering h of minus x. See what we get. We get 2 bracket minus x to the power of 4 minus bracket minus x to the power of 2 plus 5. This gives us 2x to the 4 minus x squared plus 5, which is exactly the same as what we started with. So this is h of x. This implies h is an even function. Let me try the last one. So we start with k of x. We enter in negative x. This gives us minus x cubed plus 3 bracket negative x minus 1. Opening the brackets, we get minus x cubed minus 3x minus 1. If we factor out the minus 1 here, we get minus 1 x cubed plus 3x plus 1. Now inside this bracket here is not quite this. We nearly did it. If it wasn't for that minus 1, this would be even. But the minus 1 makes it not even. Take the minus 1 away from the original function, and this would have been an odd function. Because this is neither, this is not equal to k of x, and it's not equal to negative k of x, which implies neither even nor odd. Have a go at this exam style question. I'll give you a timer.
Okay, this time because I just saw it and you were busy writing this code.
Okay, let me just finish this class off and we'll meet during proof time, if that's okay.
Okay, yeah.
Busier than I thought I would be. Okay, that's it. What do we have as our answer here for this one? C. C is the correct answer. Our last one for today. Have a go at this one. I'll start your timer. Okay, that's it. Let's have a look. Let's have a look. Which one do we think it's going to be? B. Can we prove that? Let's take P of minus x. Let's take P of minus x. It's equal to A bracket minus x to the 2k plus B bracket minus x to the k. So if k is even, then so is 2k. So if we expand the bracket, that means we get A bracket x to the 2k plus B bracket x to the k, which is equal to P of x, if j is equal to 2k and k is even. This implies that it is even. That's it. So you have quite a bit of work to do from this lesson. We got 2 worksheets, classwork worksheet and a homework worksheet.
You need to do both.
You need to do both. You need to do both. You'll also find for the weekend on the AP classroom, there are some practice questions for the minor, which is on Wednesday. We have a lesson on Monday on end behaviors, but you have some practice questions as well that you can get started with, just like the 2 I just did, so you can prepare for the minor on Wednesday.
Wait, we don't have.
We'll have most of the class is only dealing with the minor on Wednesday.
I came to 3 lessons.
You need to see the AP coordinator, Pamina, Mr. Wong, something or other. She's the classroom just here. Yeah. No, mostly 18 multiple choice questions and then an MCQ. No, an FRQ. MCQ is multiple choice. FRQ is free response. The free response is quite easy. It's like you've got a function. What are the roots? And your x equals this. And then how many multiplicities does it have?
Everything you try is last.
I wanted to ask you for the what do I need to know? I need to know how to graph.
Yep. Sorry. our IM2 and IM3 courses train students on calculators. I won't be retraining on those things, those points. I'll be showing you how to do the new stuff, but you should know by this point your basic graphing skills.
Yeah, I never took IM3.
Did you do IM2?
I know how to do it. I just don't know the calculator part.
It's part of the course.
I used to be a different school. I just don't know.
Okay, you need to know how to graph, how to find the roots of a graph, how to find the extreme points, the maxima, how to solve equations using the equation solver. These are the basics.
Wait, so on the AP website,
This boy came to us.
Can you show this slide again? KX6.
What's the question?
There was a slide here.
on the AP website, it says, will there be practice for these questions, for these child questions, AP website.
On the AP classroom, there is 18 of these questions assigned to you as preparation for the minor.
I'll do it.
You should do them.
So basically the takeaway is that
Tonight, get into the AP classroom and have a go at the 18 questions, covering the content that we've done, and you'll get an idea of how you're doing.
I think I already know, but basically I wanted to say, so the difference between AP and HPSI, the topics that you cover are different, or are they relatively the same?
So we'll both do polynomials, but our starting point and our ending point in that topic is different.
Is that the only thing, or is that something else?
No, we do a bunch of things differently on this course.
So like the AP, for example, apart from polynomials, what is the difference between the high school and the AP?
So in general, where you start is further back on the continuum, because we do polynomials in grade 9. We look at polynomial vocabulary, like what's the lead coefficient. We look at how to solve quadratic polynomials. Then we do polynomials in IM3, the same topic, but further along the continuum.
What is IM3 exactly?
Integrated Math 3. So you can get it on the Algebra 2 course or the IM3 course. So when you do polynomials, you can do them, and there's a bunch of things you can do. There's things that aren't on this course that come after. So when we have the topic polynomials, it comes up as a unit every year in every course. But if you imagine it as a sliding line of knowledge, from just being able to say, oh, the lead coefficient is this, to being able to analyze them and draw them from hand, it's a long continuum. So what we do is we assume knowledge of solving higher order polynomials and graphing them, the shape of the graph. Like you saw, when we know what the end behaviors are and where the roots are and what the multiplicities are. Our starting point for that is solving inequalities. That sign table. You notice I slowed down on the sign table thing. I made a very specific video for it, and I showed separate to the others, because the first bit was revision. There is me reviewing that topic. Then I went on to teaching the new content, and I went a bit slower there.
All right. So basically, it's relatively the same, but the start and ending point are a bit different. That's all.
Yeah.
Don't mind me coming in as well, just you can give me some stuff if I understand.
Yeah.
So, do you have a calculator charge of value? Because our class is last block and this one doesn't have any value.
You want to leave it with me to charge?
Yeah, yes, please. I have my link here on this cover.
Can I get this posted?